Hey, what is going on? It is Saturday, April 30th, 2022, and I am in that mood again. You know what that mood is? Coding a algorithms problem. Okay, well, welcome to Coding with Chef, where you get your coding needs satisfied, at least when it comes to algorithms. I still don't know what a good slogan is, but yeah, bear with me until I figure it out. It's Saturday. It's a very nice day outside. Gonna be a busy weekend for me because I have a lot going on. But I just want to say that I'm on my street to write a coding problem every day. And just let's keep that going on. So today it is an easy Saturday, and I just picked typically the way I pick a problem is I kind of go through an easy problem in the morning. I do practice on more complicated problems later on because I eventually want to get efficient at doing those. So at some point I'm going to be doing medium problems pretty consistently on this channel, but for now I'm sticking with the easy to sometimes medium. One day the gold standard would be doing hard problems. But today, the problem that I got is a random one called check if an array is consecutive. So before I begin, remember to like, subscribe, comment, and give me some love and feedback. Okay? Helps me make the channel and my motivation ramped up so I can keep making videos for you. Okay, cool. So the problem is 2229, check if an array is consecutive. Okay, so this is an easy problem. I'm gonna put a like to it. Given an integer array nums, return true if nums is consecutive. Otherwise, return false. If an array is consecutive, it contains every number in the range x to x plus n minus 1 inclusive, where x is the minimum number in the array and n is the length of the array. Okay, so basically the example will tell us all we need to know. You have a bunch of numbers, you have 4 of them, and the array is 1, 3, 4, 2. So does this array contain all the numbers in the range 1 to 4? Okay, so that's because you have the minimum is 1, the maximum is 4, and then you just want to check if all those numbers, so basically the difference between any two of the numbers in order is 1. Okay, so obviously the first thing that comes to mind in a problem like this is, well, okay, you could probably do something like sorting the array. And if you sort the array, you got 1, 2, 3, 4, and this is, going to be an O n log n, and this becomes a trivial solution, right? Because all you need to do is take the difference between all of these guys, right? And you keep the max and the min in mind, and you take the difference and just make sure it's 1. That's a good solution, but that would be too easy, right? Because that's trivial, since the machine can sort for you pretty easily without you doing anything. So whenever you see something like this, you always want to think about what is the more efficient solution. And I like problems like this because they're pretty straightforward, they're simple, but they always kind of have a way to help you highlight the difference between space and time complexity, which I will show you, the space-time complexity trade-off. So first, instead of just sorting, what we're going to do, I'm going to first check a very simple condition. Length equals 1, return true. Okay. So if we have a 1-element array, this whole thing is true by default, right? Because in a 1-element array, that element is going to be the only thing consecutive with itself, regardless of any other value in the array. So what I'm going to do, I'm going to keep a minimum, and I'm also going to keep a maximum. And this is important because consecutivity isn't the only criteria here, okay? Because if you had 4 elements, but you started at 3, and then you had 3, 4, 5, 6, 7, or 3, 4, you need to make sure that the range, the elements are within the range, okay? X to x plus n minus 1, okay? And we can make sure that's the case. We can also we also have a few other things that we can do, but keeping the min and max is going to help my algorithm out, at least the way I want to do it. So all equals new Boolean, and you might ask yourself, what's this? Okay, so this is how I'm gonna do this. This is a frequency array here. Okay, this is so basically I can check if all of 3 is true, then I've seen this already. If not, all of 3 equals false by default, and then I set that equal to true. So this is basically a hash map, but this is more performant than a hash map because it doesn't go through all the structures of the hash map. I've gone through this before, and the reason I can do this and not necessarily need to use a hash map is because I have my number range being constrained from 0 to 100,000. So that's why it's 100,001. Okay, just a little trick. Usually these kinds of tricks turn this problem into a constant space problem and end up making the problem faster. So this is the non-stop length -1. Okay, I'm gonna iterate through my array, and first, as I iterate through my array, I'm gonna check if the number exists in my frequency map. If that's the case, return false, because if I have a duplicate in here, if I have 1, 3, 1, 2, 2, 4, okay, then all the elements fall in the range, they're not consecutive, and I know they're not consecutive because 1, there's a duplicate, and 2, they're, you can't, it's not going to have all the numbers within the range min to max, right? So this kind of accounts for everything in this, but we have to do one more thing. First, I'm going to record the min and max. Min equals math.min, I min, max equals math.max. I gotta love Leetcode autocomplete. Okay, so I'm getting my min and max, and I'm just checking if max is greater than min plus num.length -1, and return false. Now, let's see, else return true. Return true. Now let's see what happens here. So basically, I'm just checking with if the range is within the range that I need to be successful with this problem. Okay, so what happened here? Okay, so one thing we have to keep in mind, okay, and we need to check nums I equals true. Remember, we need to set the value in the map, right, in this frequency map once if we haven't found it, so that the next time it's checked, because this is a case that could throw this entire thing off, because for all other intents and purposes it's right. All the numbers are consecutive, and but they do have duplicates, and so okay, so there you go. So this worked out. Now just to verify that we do need the min-max condition, let's see, let's get rid of min and max. Let's get rid of min and max. There you go. See, because in this case we have the max, we have this is another way we don't know we have consecutive numbers. All the numbers are different, so the map does take care of that part, but the size of the last element is larger, and therefore that will fool this range check here unless we keep track of the difference between the min and the maximum at any point. Okay, so once again, run it just for posterity, and there you go. Okay, great. And so this is again O of n time solution, and it's would be an O of n space, but it's a constant space solution because we're constantly using this much space. But again, this much space in the amortized sense is less than using a hash maps overhead, okay, to do addition and subtraction. You can even do timing on a hash map. It's doing the same thing, and it has less space, but not overall, because there's a lot of other functionality going on under the hood. Okay, so that's it for this problem. If you like this problem, you know what to do, and I will see you next time. Thanks for watching. Oh, and one last thing, I always write the discussions here for anybody who wants to know. This discussion is mine. Okay, I write this for every single problem I do, and as you notice in my discussion, the number is the first time I ran it, it was a pretty high amount, and that's probably because I did it for the first time. Okay, I'll see you around. Thanks for watching, and bye.